Okay guys, so we're using this motor that we ordered from Michael's group, and I did a little bit of data analysis, went through this data sheet, and here's some of the things I found. This motor has a 1.8 degree per step. Now if you take 1.8 obviously divided by 360, you're going to get 200 steps per motor revolution. Other data sheet specs I found were these values right here, as you can see. Now I plugged this into a calculator I linked in the email, and taking these values as well as this 200 steps per revolution, it got me a speed about 1.75 revolutions per second. Now if you take this number and you do some another basic conversion using a circumference of a wheel. Now I assumed instead of the circumference, the diameter of a wheel. Now I assume that the diameter of the wheel, and this is a rough estimation, but I assume there would be about 2 inches, which if you look, is pretty close to about the diagonal width of this stepper motor. Nevertheless, it's 2 inches, so if I plug in 2 inches, use C equals 2 pi r or pi d, go through all the calculations, it comes out to about 3.5 inches per second. And I explained this in the email, you can look at that if you want. But you get about 3.5 inches per second is how fast this shaft would be turning at a maximum capacity. Now if you think about that, in 5 feet or 60 inches, it would take, from what I calculated, about 17 seconds to go 5 feet. And that's just way too long for this motor. Not to mention this motor is extremely heavy and burdensome. I mean, the torque value on here that we just need to drive our Micromouse has to be high just to move this motor. So, I mean, to go 5 feet or 60 inches would take about 17 seconds, which is, for Micromouse, seems to be too long, especially at the maze navigation. So that's something to keep in mind. I'm thinking we should definitely go with a lighter and faster motor. I'll be looking at some motors later and talking to you guys about it, but definitely look over my work. I explain it in the email, and I could have made a mistake in any one of my calculations, but it appears that this motor is just way too slow. Anyways, think about it, and we need to come to a decision soon of what type of motor we should use, whether it's a stepper or a continuous DC motor that we use an encoder at the end with a feedback loop to control it. We may be able to find some stepper motors that are better. They do allow good control from the user and they're open loop, but this motor in particular seems to be way too slow